Hi, everybody. Welcome to our Azure Data Academy series. This session is on Postgres, specifically Azure Database for Postgres Flexible Server. My name is Brian Hittney. I'm a cloud solution architect focused on data and analytics. And I'm joined today by Gennady Kostinsky, who's a senior PM on the Azure Database Engineering team. You can find all of our content at aka.ms/ADA. A little bit of overview of the Azure Data Academy. We're doing data-centric presentations and also supplementing that with some hands-on material designed to help educate and accelerate our partner solution development and practice development. We're going to focus on all things data, so SQL Server, MySQL, Postgres, Cosmos DB. This is going to be very similar to our Modern Analytics Academy, which is aka.ms/MAA, where we focus on all things analytics like Synapse and data lake and all the technologies that are in the analytics space. Naturally, there's quite a bit of overlap. So you can find all of our content on our partner readiness repo, aka.ms/partner readiness. And if you have any feedback on today's session, you can give it to us directly through this page in our repo, which is aka.ms/ADA. Or if you prefer to just give direct feedback through our Microsoft Office forum, you can do so at aka.ms/ADA-feedback, and we welcome all of that for any feedback you have, and also if you're interested in future sessions. So for today, let's get right into it. And Gennady, I'll turn it over to you.
Of course, thanks, Brett. So, hello, folks. This is Azure Database for Postgres Flexible Server Technical Overview. My name is Gennady Kostinsky. I'm a product manager for Azure Database for PostgreSQL in the Azure product group. Get in touch with me via my email at gennadyk@microsoft.com. So, Postgres and the cloud. So PostgreSQL by itself is a very popular database. It's probably the most popular object relational database out there in the market, and it brings a lot of things that are interesting to today's enterprise running in the cloud. It brings in ability to run JSON, geospatial, constraints, full text search, rich indexing, and of course extensions. These unique things for Postgres that can essentially change the behavior in Postgres in an interesting way to make it run as something different than a typical relational database. But what do you get from putting it all in Azure? Well, you get other things that Postgres doesn't quite give you immediately. You get ability to scale up and out. You get compliance with a lot of industry certifications. You get ability to monitor and get an intelligent performance tuning on your instance or server. You get extra security, Azure security. You get global reach with data centers all throughout the world. And integration into ecosystem that has already built in ETL, big data, data warehousing and other big tools, right? Data tools that can be used with your Postgres together. You get automation for your management, and you get high availability. We'll talk about some of these details today as well. So today we have 3 offerings for Postgres. Kind of an older offering called Single Server, and the offering that we're going to be talking mainly about today, that's offering is called Flexible Server, and our offering, which is kind of a multi-parallel processing offering that kind of allows you to do a scale out in kind of big data, more analytical scenarios called SQL. It's called Postgres Hyperscale, right? So that's what you get today from us. What do you get from Flexible Server that kind of helps you out and gives you value for Azure, right? You get an ultimate control and flexibility for databases. Obviously, a Flexible Server actually reaches out and does a lot more in that area compared to our older offering, because you get a new custom maintenance windows. A lot of folks are kind of wanted more control over when their maintenance is done. You get burstable instances, which allow you to do a lot of more development on, in a budget. And you get stop and start capabilities, also great for your development, your developer needs, where you can start and stop your servers on demand as well. You get a fully managed server service with redundant HA, AI-powered performance optimization, and advanced Azure kind of security. You get all the open source engine, open source tools, and open source extensions that gives you a full compatibility to open source PostgreSQL, which actually gives you an ability to migrate if needed from between the platforms, gives you that ability to move and be completely compatible to open source community PostgreSQL engine. And in case of Citus, it gives you that ability, or hyperscale, what we call, since we purchased the Citus technology. It gives you pretty unique capability to build massively scalable PostgreSQL apps by scaling to possibly hundreds of nodes, right? Without attempting to rewrite code or rewrite your app or whatever. So today we're going to be talking about flexible server, and I'll kind of go through an architecture, why we decide to build flexible server versus our older offerings, and some of the most important features. As we talked about, some of the things that folks came in and asked us when we started working with Postgres and with our older single server offering had to do with a lot more control they wanted in their database. They wanted it built on a dedicated hardware. They wanted to remove kind of noisy neighbor problems, kind of things sitting together on the same rack, so multi-hosted. They wanted zone redundant high availability, an ability to kind of fail over between zones within the region. They wanted the ability to collocate application and their backend in the same availability zone for those latency kind of sensitive applications. And they wanted a simplified kind of a developer experience, ability to stop, start, save money with burstable instances. And they were explicit about keeping full compatibility with community PostgreSQL, no forking difference, something that gives you platform portability as well. So today's architecture is different from our older offerings. So the flexible server actually is deployed under the covers as a PaaS service on its own Linux hardware. So you're not hosted on common or shared hardware. What does that do for you? Well, what it does for you is it removes that noisy neighbor problem. You don't have a problem with kind of sharing resources and somebody else, and having an issue with somebody else who is under provisioned, over provisioned their resources, taking some resources from you. It also gives you an ability to run within a availability zone. And it gives you an ability to also connect to a premium storage, your own premium storage, where you're going to store data and logs. Now, together with VM and premium storage, that kind of builds up that flexible server offering on dedicated hardware. And of course, you may deploy your front end in the same availability zone or other availability zone, depending how you build your application. And that front end could be in a VM, it could be in Kubernetes, it could be an app service, it could be in various places. And then we allow you to actually do a zone redundant backup. So if the zone fails, not just your server can, by default, if the zone fails, your backup has a copy in a different zone. So that is kind of by default what gives you that capabilities of with dedicated hardware and zone redundancy. The compute, what do you get in terms of compute and storage? Well, by default, you get burstable instances, which are great for development. These are little itty-bitty instances, 1 to 2 cores, fast for like workloads that don't need a lot of CPU, something you want to quickly throw in, try, and then not pay a lot of money for a little development activity. You get general purpose, you get memory optimized, which is your usually production deployments need. And at the moment, the limitation is that the system is taken offline for scaling. When you scale CPUs, we're working to kind of get rid of that limitation in the near future and kind of keep the system online while the scaling happens. As far as storage, you get premium managed disks. You get anything from 32 gigabytes to 16 terabytes. You can scale those in only a few clicks. And the limitation today, there is no auto grow. So we don't auto grow, so you have to actually watch your storage. But we're looking again in the next months to a year to remove that limitation and kind of build an auto grow into the system. Backup and restore, which is important for DBAs. So today it's a PaaS service, so we back up for you, and we have retention anywhere between 7 to 35 days. You can set that up. We do kind of a daily data disk snapshots, and we archive your write-ahead logs to the storage. So you can restore to pretty much point-in-time restore by applying a backup and a log. You can, when you want to, through the portal or through API, you can do a restore in time to the latest time, or you can pick a custom time in case something happened afterwards and you want to restore to an earlier time than the latest time. You can restore to the same availability zone or a different availability zone. And now we have a geo backup and geo restore functionality. We'll talk about that. That's when you have a backup copy to a different region in case of a regional failure. And that gives you about 1 hour of restore time, of restore point. So possibly you could get to 1 hour of data loss because the copy takes a bit from one region to another. But at the same time, it's a good DR functionality, because even if the most you can lose is 1 hour worth of data. So we talked about backup and restore a lot quicker. Just remember that, right before this. So just remember that you can also use a different server name. So a lot of folks, for their development servers or for their development, just do a quick backup and then restore it to a different server, right, if you need me. Flexible control. So this is something else that folks in our earlier offering asked for, and we kind of worked a lot to give them what they're looking for. Maintenance. This was one of the biggest sticking points in the older single server offering. In the older single server offering, you had a system-defined schedule where we kind of did your maintenance. We just gave you some notice and kind of did your maintenance when we did your maintenance. Just get ready for it, right? Simply because, again, you didn't have dedicated hardware. We couldn't build maintenance for you. So in this case, you have an ability to do a custom schedule, go away from that system-defined schedule, and pick up a day of the week and pick up the start time and schedule your maintenance per server. And it's about 1 hour maintenance window. Expected downtime to be less, about 60 seconds. In the worst case, sometimes we have to reboot a VM if it's a Linux patch or something in that nature. And we do this maintenance about every 30 days. You still get the 5-day advance notification, just like you get with the system managed schedule. But that gives you a lot more control over your maintenance. We're also looking to kind of let you pick the week of the month, not just day of the week. That's going to be coming in sooner or later. We're looking to do that as well, to give you even more control over your plant maintenance. Network isolation. So obviously, a lot of our bigger customers and the customers that need better level of security ask for private access or VNet integration in Azure. So the public, there's no public IP, there's no public endpoint. We can talk about it more, but at the end of the day, that gives you fully secured virtual network where you can roll in your database server. The public access is also be controlled by restricting by firewall rules. It's kind of an old-fashioned cloud security, and you can just add whatever firewall that allows your client to come in, right? So by default, everybody's out, nobody's coming in, but you can add a particular IP range or an IP of your application server that can log in. Private access is a little more complicated and a little more sophisticated. We use VNet injection architecture to inject flexible servers to delegated subnet in Azure VNet, and client can be in the same VNet or in different VNet. Sometimes you have clients that are sitting in a different VNet or a different region, and then in this case you peer one VNet to another VNet, and you have visibility between these VNets, and they can communicate to one another. Authentication methods. So both authentication methods of SHA-256 and MD5 are supported. So you can choose your password encryption, and some people only want to use SHA. Some people are okay with MD5. We also by default are SSL, obviously, and we support anything between SSL 1.2 to 1.3. And you have an ability to enforce a version of SSL your client has to have in order or to use to communicate to the server. Another thing that people are asking for is the better parameter control. So what parameters are is an ability to obviously set global and per session, but in this case, it's global behavior of the database. For example, some of the auto vacuum settings, some of the password authentication method, as we talked about, like MD5 or SHA-256. Ability to how do you handle nulls and arrays, and so on and so on. So unlike the older offering we have, you have a full server parameter control through flexible server that allows you to customize your server to your needs. And in this case, I'm going to try to show you a little bit of a demo of how to set up an extension in Postgres flexible server. So in order to show you how extensions operate, I have a particular server I created. It's called extension demo, and the idea of that server, it's in Postgres, and at the moment I don't do anything with it other than created a flexible server in Postgres. So in order for me to be able to use extensions, I can go to parameters, and first I need to allow list that extension for usage. We did this just so you get a better security, because we don't want to enable by default all the extensions, and some of the extensions you just don't want to use, like DB-Link. A lot of customers don't want to use, or some other extensions. For that, you have a parameter called Azure Extensions, and I can go in and I can pick, for example, in this case, I'm going to use the PostGIS extension. So I'm going to just enable a bunch of PostGIS extensions because I'm going to use those. And you can see I selected them, and all I have to do, these are dynamic, so all I have to do is say click save, and it should be done, right? So once it's done, what I have to do here is I have to create these extensions. Go and create, let's say, 3 of these. I don't need the others to be. I just have them here, but I'm going to try to create PostGIS. I'm going to try to create PostGIS rasters. Not that I'm going to use it a lot. PostGIS topology extensions. So once these are created, now we're going to work with spatial data. We can now. Well, we're going to create a table with the geometry data type, which has a point, stores a point value. Because the PostGIS extension is the geometry extension that allows me to do a lot of kind of a Earth geometry type of storage and calculations. I'm going to create this table, and now with PostGIS, notice I can also do a gist index on that table, which is geometry. I can't do yeah, so correctly. So I'm going to select a point. Let's say it's 0, 0. It's kind of boring, but I'm going to add a geometry point to that table now. Now, on a regular Postgres, none of this would be possible because it doesn't understand the geometry as well as PostGIS does. But since I enabled that extension, now I can go in and select, run a function called within, and point some geometry data from my tables, and also use a function called sggeom from text. In other words, getting geometry from text. So, and pointing in a certain value in there. So, there's not much data in there, but the point is, that's essentially where what it gives you is the ability to do advanced geometry in a few clicks, right? You can just create this extension, first allow listed, then create it, pretty much turn yourself into a geometrical database that stores Earth coordinates in 5 minutes, which is not something easy to do on a relational database. All right. High availability is the other important item we're going to talk about really quickly. So we use zone redundant high availability where it's available in Azure. So a synchronous standby replica is automatically deployed. When you pick that option, I should say, a synchronous standby replica is automatically deployed in a different availability zone than primary. And it's synchronous, as I already stated. So you got a 0 data loss in the event of some sort of a failover, unplanned or planned. It's pretty much physically separate copy with Postgres streaming replication. Unlike Postgres, we did build an automatic failure detection and failover, so you don't have to put in any kind of extra software that does detection and failover. And that allows for high uptime during even maintenance, because if you roll out high availability, we talked about maintenance in the past, and possibly you have to restart the system with Linux patches and whatnot. Well, in case if you have high availability, now we will do failovers before we restart the system. So therefore, it allows us to have a high uptime during maintenance and unplanned, obviously, issues that you have. So this is what it looks like. If you look at the item, you see that we got a flexible primary server, premium storage that we already talked about. Then we have a standby, and you got a synchronous rep going to the standby. And then also you got the wall logs, continuous archival wall logs happening to storage. And worst case scenario, you got an automated failover that occurs if the primary, something happens to primary availability zone. This is within the region between availability zones. And theoretically, as I said before, if you have a latency sensitive app, you can deploy your front end, be it app service, AKS, Azure VM, whatever it may be, to the same availability zone and fail them over in concert together. You know what I mean? Keeping them in the same availability zone. So how do we fail over? Well, there's, also as well, first let's talk about this. Really shows you how you can pick an availability zone in this slide. You can pick, let's say here, availability zone of 1, or let's say there's an availability zone of 2, and so on. You've got 2 types of failover. You got a forced failover, you got a planned failover. What's the difference? Notice you have 2 buttons, or two. If you're doing it via CLI, you have 2 parameters you can provide. Well, the forced failover is a quick thing. It actually simulates a fault in a primary. So it simulates actually a failure of a primary server. And, then the time that's reported for failover actually includes, as soon as you fail over to secondary, it becomes primary, and it has to create a new standby creation and establishing what we call a steady state. So that time for the forced failover, when you see the time that it gives you in statistics in a portal kind of includes all that. So that kind of scares some folks, because once they see all that time, they say, why does it take so long? Well, it takes so long because even though it fails over quickly and the server might be available, it takes time to establish a new secondary or a new standby. So the downtime for the application is a lot smaller than actually the time you'll see in a portal. And then there's a planned failover. The planned failover is just something that you use for, let's say you're trying to, I don't know, do maintenance or do some testing, failover one to another, right? The important is that it provides for much lesser overall downtime, but it attempts to close the connections gracefully on the clients before failing over, because that does not, again, mimic a fault. That tries to do it properly, right? So that's a big difference between forced and planned. Region level protection. So we talked about high availability when it comes to availability zones within the region. Well, what happens if the region goes down? Well, what we have available today versus what we have available in the future. So today in a preview, you have a geo-redundant backup restore functionality where, let's say you are in East US, you do backups, you turn on geo-redundant backups, your backups are actually copied to a paired region, let's say West US for that region, for that example, for East US. So it's copied over, and then let's say region East US goes down, you can create a new server in West US and restore your backup. That's kind of a simplest, region, cross-region DR, right? The other way out, you can still build your own rep between the regions based on a logical-based replication. So it's got some restrictions to it, but it would be managed by you guys. And then finally, we do have it coming in a matter of a few months, is the ability to put replicas in paired regions. And that would be a managed server, unlike the logical replication. So you didn't have to build your own logical rep. You just tell us how many replicas you want across, so up to 5, I believe, across what regions, and we'll just replicate regions. We can actually replicate to a same region for reporting purposes or whatever else, or different region. So the backup I already talked about. Important to note that it's up to 1 hour in SLA is up to 1 hour before it's copied to a. So you may get data loss for up to 1 hour. You can restore it. You can see on the slide a couple of things. First, how do you enable the geo backup? Right there on a portal blade, and how do you restore it in a different region as well? So when you try to create a server, it gives you an ability to restore from geo-redundant backup. Some other important features that are pretty interesting, that some of these features only are unique to us on a PaaS platform. Connection pooling. Postgres connections are expensive. Right now we're up to Postgres 14. There's some significant changes in connection handling that gotten better in terms of connections, but a large amount of short-lived connections are not well handled by Postgres, and we can go into it because of dispatcher and ability to kind of spin up demons per connection, and how long does it take, and things like that. So a lot of folks, when their system grows, pick some sort of a connection pooling software for Postgres. Probably the most commonly used is PG Bouncer, which allows you to put in a separate Linux VM between a client and a server and deploy PG Bouncer. Well, with us, this is unique for a PaaS service. You don't have to manage it. You don't have to create a Linux VM and put PG Bouncer on it. You can just use it as a feature. So you turn it on, We deploy PG Bouncer for you. All you have to do is now start connecting via 6432 port, and you're connecting via PG Bouncer. We also give you some ability to edit PG Bouncer parameters without going to a config, of course, because we are managing PG Bouncer for you, but through the global parameters screen or global parameters in CLI, right? So it's an opt-in feature only for general purpose and memory optimized queues. And you can connect via PG Bouncer, meaning port 6432, or for administrative things, data copies, some other things where you don't want PG Bouncer involved, or you don't want to connect through the pool, you can still connect outside of it through the port 5432, which will connect direct to Postgres. So outside of PG Bouncer. But it's still a great feature, very unique to us. There are no other PaaS vendor that offers you a PG Bouncer. On any other vendor, you would have to actually deploy your own VM, patch it, create, use it, whatnot. Monitoring, obviously, there's some metrics on overview page in a portal that shows you kind of connection, basic metrics, connections, network in and out, etc., CPU, memory, IOPS, things like that, and failed connections. So this is good for just a quick glance into metrics on a portal. Beyond that, you probably want your Postgres logs, and you can configure how many retention days of Postgres, how many days you want to keep up retention in the portal. And you can send them, a lot of the customers, what they do, they send them to either storage account or log analytics, or some of them, to be honest, the advanced customers, they stream them to Event Hub with Kafka nodes or Datadog or Elastic, and kind of get another way to search for these logs by indexing them in Elastic and things like that. So the simplest thing what I do, I put them into a storage account. You can use Azure Storage Explorer to kind of download them and view the logs. You can also set up an alerts. Let's say your CPU goes up or something happens with your IOPS or memory. You can set up an alerts, and these will alert you as well. CLI. So majority of times, we want folks not to actually use the portal, but we make sure that everything that you can do in a portal is available in CLI. And you don't even have to install CLI on your machine. Just set up a Cloud Shell, Azure. Just go ahead, and use CLI straight from Cloud Shell. Just give you an example of how you can set up an environment with 2 commands and provision a new flexible server with 1 command. Some time ago, we spent a lot of time optimizing CLI, so it can be as least verbose as possible. So you can do a lot of things with 1 or 2 commands, just typing a lot. See, every time you create a server, you can go all the details. These parameters are optional. So if you just want to create one using defaults, AZ Postgres Flexible Server create. It's done. Cost optimization. So for a lot of our partners and a lot of our developer folks that develop, it's very important. They want to optimize their costs using the platform. For that, there's a couple of things. Number one is the burstable SKUs. Probably the most least expensive ones are starting at less than $15 a month to this day, but the inflation for all the development needs, right? So you can set up a pretty small something in order to kind of make sure you can run it, and you can test your code for less than $15 a month. Or another way, if you want something bigger and you can set up any server, right? You can easily stop it when it's not in use. And at that case, you're only paying for storage. You're not paying for CPU. And because we need to maintain it, back it up, we actually will restart it on our own after 7 days. But you can always stop it later. So that's pretty simple. Some of the important partners and customers that work with us, I think the most known one is SAS, or Scandinavian Airlines recently. Munich Re is a big insurance company in Germany that's doing a lot of things with us with Postgres and Azure. QBB, another railway. We seem to have a lot of railway customers, anything from Canada to Europe, right? And then Ubiquity is like an investment analysis company. So quite a few customers, and we are adding more and more every day. Thank you, everyone, and appreciate your attention, and free to reach out to us for any questions or anything we can help with.
Thank you so much, Gennady. We appreciate your time today for presenting in our Azure Data Academy. As a reminder, all of our content will be up at aka.ms/ada in our partner readiness repo. We do appreciate your feedback and contributions. So within the repo, you could either leave feedback directly there using the GitHub issues link, or through our feedback form, which is aka.ms/ada-feedback, that will send us an email with any suggestions you have for future sessions. We're going to dive into Postgres extensions a little bit further in our next session with Gennady, and then we also have some MySQL content that will be coming very shortly, and we look forward to seeing you then. Thank you very much.